Alright, this is day 4 of notes for EUS 2A. We're solving quadratics using square roots. So remember that if you're solving a quadratic, it's got an x squared of highest degree. This one is in standard form. So don't forget too, your solutions, your roots, your zeros, your x-intercepts are where the parabola crosses the x-axis. We have two solutions here. There are no real solutions in this one. And down here you have one real solution. Okay, so today it's using square roots. Okay, you can't use this all the time. The best time, basically the only time to use it, is when there is no bx. Do you remember what we call that term? It's our linear term. Okay? You're going to use solving by square roots when there is no bx or your linear term. Remember, your bx term is that one right there. So that's what we're going to do today. So first of all, don't forget, when we simplify square roots, I forgot some letters in there. When we simplify, there we go, square roots, we consider only the positive terms. Okay? So, let's simplify square root of 20. We haven't maybe done that in a while. Think of what perfect squares go into 20. That would be 4 times 5. The square root of 4 is 2. The 5 stays inside. Now when we solve square roots, how do you know you're solving instead of simplifying? You have an equals in the equation. It's an equation. We must consider both the positive and the negative roots, solutions. Okay? These are just your positive terms or roots. Probably could have put that up there too. Alright, so here you're going to square root this side, square root this side, so x is going to equal, we know it's going to be 2 square root of 5, but the positive number works, also the negative works. If you think a minute, square root of 4, that could either be positive 2 times positive 2, square root of 4 could also be negative 2 times negative 2. So when we simplify, we only look at your positive answers. When we solve, we are always going to have the plus and minus. So that means I actually have how many solutions? 2. Alright, so let's go down here and try one. First thing we're going to do, let's go ahead and jot our processes while we're working on it. First step, what do we do first? It starts with an I. Isolate. That's almost always our first step when we're solving anything. Isolate first. In this case, we're going to isolate the squared part. Okay? Which, it's your x squared. So in this case, it's a p squared. So divide by 3 first. P squared equals 63. Then, you go ahead and how to get rid of the square root. So p equals, and just get in the habit, plus or minus, put that first. And then we go, okay, 63 breaks down into 9 times, good, 7. So the square root of 9 is 3. We're left with the 7 on the outside. And there's our answer. Now, why do I have this little axis here? Because I want you to realize when it crosses on the graph, we have two different answers. Now if you look at this problem, what is your A value? Your A value is positive 3, right? So we know the graph's going to open up somewhere. It's going to cross here at a negative 3 square root of 7, and it's also going to cross here at a positive 3 square root of 7. So trying to get you to see, here's our equation, this is what we know from it. Alright, come over here to number 2. Isolate the squared part first. So I need to get rid of the negative 6. So add 6. Okay, then how do you get rid of a dividing by 25? Okay, well, for dividing by 25, to do the opposite would be to multiply by 25. And then those cancel out, and now you're just left with the x squared. You've isolated it. 4 quarters is 100, or $1. Square root both sides. As soon as you square root, what are you going to write down before you forget? Plus and minus. Square root of 10 is even number 10. Square root of 100 is 10. Alright, so what would that look like in a graph? You've got your negative 10 here, you've got your positive 10 here. Again, I know this one's opening up because my A value is positive. So let's jump down to number 3. Actually, this is in vertex form. Would be easy to graph if we needed to, but we really aren't graphing. We are trying to solve for x. So my first step is to isolate. Now look at this one. My squared part is the whole thing. So in this particular problem, my squared part isn't just an x, it's an x minus 4 squared. So that means I want to get rid of everything that's outside this part. Get rid of it first. So what are we going to get rid of first? The 2 or the negative 38? Hope you said the negative 38. We're going to add it over to the other side. And I have 2 times the quantity x minus 4 squared equals, this will now be 48. Do not ever try to multiply this through, because to begin with, this is really x minus 4 times x minus 4. You'd have to multiply that out first. But the whole thing is to isolate. So we're going to divide both sides by 2. Those cancel out, and now I have isolated my squared part. And from here, I square root both sides, and I get just x minus 4 equals plus or minus. Okay, so 24. That would be, the perfect square that goes into that is 4 times 6. Square root of 4 is 2. Left with the 6 on the inside. But on this case, we're not done right here. If you look, we still have something over here with the x, and we're trying to solve for the x. So how do you get rid of a negative 4? Add 4. What do I add 4 onto over here? Can I combine a 4 with the 2 square root of 6? No. You cannot, because this doesn't have a square root of 6. So you're going to leave your answer as x equals 4 plus or minus 2 square root of 6. Cannot combine unless these both have square roots of 6's. That is your answer. Alright, so one more here. Well, this one's really easy. I don't know why we didn't do this one first. I've already isolated. There's nothing to isolate. After you isolate, I guess we could put, then you square root both sides. I'd put a 3. Remember your plus and your minus. Alright, so square root, x plus 2 equals plus or minus 9. Oops, 7. So x equals, subtract 2 over. Now, does this have a square root in it? No, this one doesn't. Can I combine these? Yes. You're going to get 2 answers. You're going to have negative 2 plus 7. And you're going to have negative 2 minus 7. So negative 2 plus 7 is 5, and this is a negative 9. I have 2 answers, but I can actually write them separately when neither one of them has a square root. Can you leave your answer like this? No. If there's no square roots in it, you have to switch it into the 2 answers. Alright, so let's flip to the back side. What's left do we have to do? One more with fraction, and then we're going to look at imaginary. So on this one, we're going to isolate first, so we're going to add the 66 over here. Okay, how do you get rid of the 2/3? Fastest way would be to multiply by the reciprocal. 3 over 2. Now, if you would rather multiply both sides by 3, I'll just do that over here this way too. Somebody would say, well, I would really rather just multiply it with 3, cancel those out. Oh, that is 66 times 3 is 18, 198, and then divide both sides by 2, and x plus 8 squared equals 99. If you do it this way, it's one step. Everything over here cancels, so you're just left with x plus h squared equals, let's see, I can put a 1 underneath and cancel. 2 goes into there once, goes into there 33. 33 times 3 is 99. Either way I get to the same thing. And then you square root, and x plus a equals plus or minus, okay, so square root of 99. That would be 9 times 11. The square root of 9 is 3 times square root of 11. We're not done because I have the 8 over here, so move it over by subtracting negative 8 plus or minus 3 square root of 11. Again, you cannot combine these because this has a square root of 11, this one doesn't. So there's your answer. We're not going to graph it. Alright, so sometimes we get imaginary answers. What would a parabola look like that has imaginary solutions? I gave you the hint back on the other page. Because I said this has 0 real solutions, but guess what it does have? It has imaginary. So you could put it anywhere you want on here. You could put it there, it just cannot cross the x-axis. So you get imaginary answers when the graph doesn't cross the x-axis. So as long as it doesn't cross this, you're good. So let's recap. What's the first step when we solve square roots? Isolate. Which part? The squared part. What's the proper form for all complex numbers? Remember last lesson we learned about imaginary numbers, and when you leave your answers you do a plus bi, the real part, the imaginary. How come I know it's imaginary? Because it's got the I. Alright, so let's try one that's going to give us an imaginary number. Square root, okay, I forgot to say, check isolate first, but there was nothing to isolate. So I square root both sides. X equals, what happens when you square root a negative number? You know you get an I. So what does 24 break into? Well, it's a negative 1 times 4 times 6, right? Square root of a negative 1 is my I. The square root of 4 would be 2. The 6 doesn't come out. And what did I forget? Daggone it, I left it out. What do you always have to do? Plus or minus. I didn't leave any room. That's it. Jump over to 7. Isolate first. Subtract the 11 over. X squared equals a negative 8. Square root both sides. And this time, what do you write first? Don't forget, plus or minus. It's got an I in it, so we know we're going to, for a negative, it's going to have an I in our answer. Negative 1 times 4 times 2. 4 is the perfect square that goes into 8. Square root of 4 is 2. Left with the 2 inside. 2 more, and we're calling it done. So if you want to pause these and try these before I do them, you're welcome to. Otherwise, we look at this and it's isolated, so we're going to square root. So 2y minus 3 equals plus or minus, plus or minus. It's a negative, so you know we got an I in it. So 45 is 9 times 5. The square root of 9 is 3. 5 has to stay inside. It's not a perfect square. Ooh, we got a lot of big mess over here on this one, right? It's fine. We're going to add the 3 over. So we'll have a positive 3 in the front from where I went plus 3 plus 3. Cannot combine these because this is I square root of 5. This one doesn't have an I square root of 5. And the last step is you just divide by 2. And all you have to do is put that underneath. So y equals 3 plus or minus 3i square root of 5 all over 2. Hot big mess, but that's it. You will have some answers that look like hot big messes. That's life in Algebra 2. Alright, last one. Stuff on the outside, so we're going to have to isolate first. So x minus 3 squared equals a negative 2. We're done isolating, square root. You square root, how many answers are we going to get? 2, so don't forget your plus or minus. 2 doesn't simplify at all, so we're going to have the I on the outside with the 2 on the inside. Add your 3 over, and x will equal 3 plus or minus I square root 2. And that is all she wrote.